Every quarter, a few million people refresh the same page, hunting for the same number. How many chips did Nvidia ship? It's the wrong number. It has always been the wrong number. Here is the one nobody is watching. Nvidia sells engines, beautiful, absurdly expensive engines. And for most of this company's life, that was a terrible business to be in. Rewind to the 90s. Nvidia is one of dozens of graphics card companies, and it nearly dies twice. Its customer is essentially a teenager who wants prettier explosions, and the whole business swings on whether this year's games happen to be good. When crypto miners pile in, the stock triples. When they leave, it gets cut in half. It lives and dies on the product cycle like anyone who sells a thing in a box. So the market priced it like a box seller. For 20 years, analysts asked box seller questions. How many units? What is the average price? Is the next generation on schedule? And while everyone stared at the boxes, Nvidia's co-founder, Jensen Huang, was doing something no box seller has ever done. He was pouring billions of dollars every year for 2 decades through crashes and crypto winters into software the company gave away for free. So, what is a graphics chip actually? The processor in your laptop is a genius. A few very fast cores that can do anything. One hard problem after another. A GPU is the opposite. Thousands of tiny, stupid cores that can only do simple arithmetic, but can all do it at the same time. For drawing pixels, that is perfect. A screen is just a few million small, identical problems. In 2006, Nvidia's engineers noticed something. Physics is not a screen. Neither is weather or protein folding, or it would turn out a neural network. But they are all the same shape of problem. Millions of small, identical calculations that do not have to wait for each other. The chip that draws your explosions could, in principle, simulate a galaxy. In principle. Because talking to a GPU was hell. You had to disguise your physics as a graphics problem, feed it in as fake pixels, and pray. Almost nobody bothered. So Nvidia built a door. They called it CUDA. A way to write ordinary code in an ordinary language and have it run across thousands of cores at once. Released in 2007, free, and nothing happened. For years, CUDA was a research curiosity, an expensive gift almost nobody unwrapped. Nvidia kept paying anyway. They put CUDA into every chip they made, including the cheap consumer ones, so any student with a gaming PC already owned a supercomputer. They wrote the libraries. They ate the cost year after year while the market yawned. Then, in 2012, 3 researchers in Toronto trained an image recognizer on a pair of consumer gaming cards using CUDA and beat the entire computer vision field so badly that the field stopped doing it the old way. That was the moment. Not because Nvidia had the fastest chip, because every researcher who wanted to repeat that result had exactly one door available. And here's the thing about a door everyone walks through. It becomes a hallway, then a corridor, then a city. Because CUDA is not one thing. Underneath the models you have heard of is a stack. A library for the layers of a neural network. A library for chips talking to each other. A library for squeezing a finished model down so it runs fast. Compilers, profilers, debuggers, drivers. 2 decades of boring, load-bearing plumbing, nearly all of it written by Nvidia, all of it assuming Nvidia's hardware. Then the rest of the world built on top of that. The frameworks researchers type into are, underneath, hand-tuned code aimed straight at Nvidia's chips. On top of the framework sit the models. On top of the models sit the products. And on top of the products sits, increasingly, the economy. This is the part a shipping number cannot see. Nvidia's real product is not on the invoice. Nvidia's real product is that the entire AI industry writes its code in Nvidia's language, and has done it for so long that the language now looks like the laws of physics. Which brings us to the only number that matters. Suppose you run a giant tech company. A competitor offers you a chip that is genuinely cheaper per unit of compute. Do you take it? Do the math the way your engineers will. The chip is a rounding error next to the migration. Every routine your team hand-tuned has to be rewritten. Every result has to be revalidated because a model that trains subtly differently is a model you cannot trust. Your best engineers, the ones who should be shipping your next model, spend 2 years doing plumbing, while your rivals sprint ahead on hardware that already works. And at the end of it, if it works, you get roughly the same result. Slightly cheaper, 2 years late. That is the moat. It is not speed. It is regret. It is also how a hardware company holds software margins. Nvidia keeps more than half of every dollar it collects as profit, not gross profit, net. Its customers carry the risk, the rewrite, and the bill. But every toll booth attracts an army, because that margin is not paid by strangers. It is paid by the richest, most technically capable companies that have ever existed. And they hate it. Every dollar Nvidia keeps is a dollar out of their budget, and they employ the exact people who could build a replacement. So they did. Google has designed its own AI chips for a decade. Amazon designs its own. Meta, Microsoft, the Chinese giants, everyone with enough scale is trying to build a road out. AMD sells a real competitor with an open software layer designed explicitly as an escape hatch. There is more money and more talent aimed at breaking this one lock-in than at almost any other target in technology. And it is working. This is the part the Moat story leaves out. The giants can escape inside their own walls. If you control the model, the framework, and the data center, you can port one workload, prove it, and run it on your own silicon forever. Every serious cloud now runs some of its work on chips Nvidia did not make. But look closely at what they escaped into. A chip that runs their code, in their building, for their models. It is not a road anyone else can drive on. The startup renting GPUs by the hour cannot use it. The researcher cannot. The open source model cannot. And here is the trap, and it is beautiful. The moment your escape hatch works, you have to maintain it. Forever. Against a company that spends more on this software every year than you do, and gets paid to. So the giants defect at the edges and come straight back the moment they need to move fast. Nvidia loses the workload it was always going to lose and keeps the only thing it truly owns. The default. So how does a moat like this actually die? Not a faster chip. Chips get matched all the time, not a cheaper chip. We just did that math. It dies when the software stops needing to know what hardware it is running on. When the layer everyone types into drifts far enough from the metal, that swapping the metal underneath becomes boring. Compilers that target any chip, a standard nobody owns, which is exactly what a coalition of Nvidia's biggest customers is, now spending billions to build. And it is the only thing worth watching. So, when you check on this company, ignore the shipping number. Ask 3 questions instead. Is anyone's code becoming portable? Is the switching cost falling? Is the default still the default? Because on the day, a serious lab can move a real workload to another vendor over a weekend. And shrug, Nvidia is a chip company again, a very good one. In a very cyclical business. Until then, it is a landlord. And this is the shape to look for everywhere else because it is almost never in the product. The engine is visible. It gets reviewed, benchmarked, printed on the box. The road is invisible. It is the file format your industry saves in, the rails your payments run on, the language your code is written in. Nobody refreshes a page to see how the road is doing. But engines get replaced every few years. Roads get inherited. Find the company that quietly paved one before anyone noticed they were driving on it, and you have found the only advantage that actually compounds. This video is sponsored by Moat. Nvidia's moat and everything we just covered, widening moats, compounding, quality at a fair price, is simple in theory. Actually finding those companies, that's the hard part. That's exactly what MoatScope is built for. It rates thousands of stocks on the two things that matter most: how strong the moat is and how much you'd pay for it. Quality times valuation on one simple scorecard, so you can spot the widening moats that are actually trading at a fair price. Check out MoatScope at the link below and find your next compounder.